So hi, I have this LED light that I want to use as an emergency light, and it is working on 57 volts, and I have the DC to DC that I've modified in my previous video to give output instead of 55. Now it is good for 74 volts. So I want to use it with batteries, and I want to build it as a self-charging unit, which means when there is electricity the battery are charged all the time, and when the power is off this is automatically on. So I don't want to modify it, I just want to give it the required voltage, and then I will add a relay that when this is already out of source power supply from the outlet, it will automatically go on the battery. So I will show how to build it and use it, and that's all. So let's start. So the first step will be to calibrate the voltage of this unit, and as already mentioned, so it is 57 volt. I have measured it under a real configuration with the original DC to DC that came with it. So now I will apply 12 volts to my DC to DC, and I will adjust the voltage out to match 57 volts, and then we will measure what we need. Now it is 74, it's a lot, I don't want it to be 74, so let's reduce it to 57 exactly. So now we are on 57 volts, and now I will test it with the LED light to see how much power consumption I need and what is the output from the batteries, in order to know how much time it will work on batteries and things like this. So let's connect it to the LED light. Okay, so next step is of course to connect everything. So I've connected and put isolation strip. This is a shrink, and now we will test with 16 volts, because I'm going to use 4 cells of lithium batteries. So I will put 4 cells in series, so when they are fully charged, so it is 4.2 multiplied by 4, but let's say 4 multiplied by 4 is 16. I will check on 15 volts maybe first to see that it is working and see the current consumption. So on 15 volts I have 1.1 amps. Okay, 1.1 amps. So basically now it is working. So I found these 4 cells that are already connected in a parallel, and I need 4 of them, so I will connect this in serial to this, and this to this, and this to this. First I want to check the voltage that are okay. 4.1, 3.8, 4.1, and last 3.76. So they are not balanced, and I will connect and I will do the balancing between them later. Already found this BMS, I think I will use it. It should be okay. This is for 10 amps, it's more than enough for this project. So let's connect everything and continue. Don't forget, in this case I need to connect the minus to the plus and not to make a mistake, so carefully check that you are connecting everything okay. I will use this handheld spot welder, you can see it in my previous reviews, and just connecting now between this very simple pressing Very simple to use it. I'm doing many spots to be on the safe side. It looks like it is connected okay. So be careful when doing it to do it correctly. So now this connected to this, and I don't want this to be short with this, because then I will have a blow up. So I will even maybe cut the metal here, and this minus will go to the next plus. Maybe I will put it like this. I don't need these spacers. So minus to plus, not to do a mistake. This is the most important part, of course. The pulse, I can make it even stronger. Okay, and now the last one is the minus to the plus here, and then we have the pack ready. So again, using the strip, of course, then I will check that everything is connected okay in terms of voltage out, to make sure that I didn't make any mistake. Now if everything is okay, so the voltage between the minus and the plus should be something around between 15 to 16 volts. So let's check that everything is okay. Yes, we have sorry about the reflections. So again, I will show you. 15.70 something volts. So everything is connected okay. Now I will put a Kapton tape to catch all the pack together, and then we will go to the balancing and connect the BMS. So this is the battery pack, very simple. I remind you that it is not balanced very well, but we'll take care of this soon. So I have my battery pack almost ready for use. Now I need to connect all the wires out to connect this BMS board. And of course I will add a fuse of 5 amps to be on the safe side, and we will do a balancing between the cells. I will show you how. Okay, so let's continue. So in order to do the balancing, I'm using this active balancing board. I will connect the cable, and it is doing all the automatic balancing, and then it is stopping. So I will connect it and run it, and by the LED we will see that it is doing balancing, because we know that there is a big difference between the cells, between 4.1 to 3.7, something like this. So connected everything. Let's see what is happening when plugging it in. So now it will work for probably several hours, I think, and when it's finished all the cell will be more or less balanced. And let's get it to work, and later we'll connect everything to the BMS, to this BMS, and then we are done connecting everything back together with the relay. So let's wait. So what I've done, connected the BMS. This will be the output. The input is going with a fuse, a tiny fuse. This is 1808 PCB fuse with 5 amp fuse inside. And of course I will put heat shrink on this one. I don't want to expose it, so it will be fully isolated, and we'll open it just in case of a problem. And these are all the balancing wires, and this is the battery minus and the battery plus connected directly to the battery. I will add an on-off switch and close everything back together, and we'll add the relay for the charging. The input for the charging has to be something about 17 volts. Why? Because 4.2 multiplied by 4 is 16.8 volts, and the BMS of course will protect when it will be a little higher than 16.8 volts. And that's all, closing everything back and testing it. Okay, so after balancing all the cells, it's time to connect everything. Should be pretty simple and test it. I have the fuse inside that protect me from short on the battery, and now we'll do all the connections. So we start with the B minus, which is the battery minus. So I'm looking about the connection, and the battery minus is here. So this will be the first soldering. Battery minus. So connecting the battery minus. Okay, next is the B1. B1 is going after the first cells. So this will be the B1, connecting it like this. Next is B2, which is the next connection, will be connected here. Next, of course, is the B3, which are the cells here. And last will be the battery plus. Always checking that there is no short, and when there is no short we can solder it just like this. And now we should have a 16 volts, a little less, a little over 15 volts. So let's check that we have it, and if we have it, so everything is okay. So checking, and we don't have a voltage. Why we don't have a voltage? Let's see if everything is connected okay. Yes. Okay, so I had to apply a charge for a second, and then it is starting to show voltage out. I have no idea why, but it seems to be okay now. So now we will connect to the lamp and see that everything works as expected. This is of course just a first test, so let's connect and see that it is lighting. Yes, you can see that now it is lighting as expected. Now I will put isolation to everything, connect everything, and also connect this switch here. On the side I've added the switch, and we will put a relay that will do a charge to this circuit while it is plugged in. So that's all for, so let's close everything. It will be better, and I will isolate this circuit with a paper here on the bottom of the PCB, and then we'll see it again working. So basically almost everything is ready. What I've done, I've added the 12 volt relay, connected to the input 12 volt. I'm missing one part, DC to DC step up with current limit, because I want to charge this battery with the current limit. But other than this, I left all the wire to connect the DC to DC step up, and I can show you how this is working. So connecting the battery, this is the battery pack that I've made. Okay, so just need to add the circuit for the charging, and now if I press the switch, so the light is on. As you can see, it's very strong light. And now if I will connect the 12 volt to charge it, it will automatically disconnect the light. I will show you this in real time. So now I'm connecting the 12 volt, so you can see the light, and now I will power it up and tuck. It is disconnecting, and in this way it will charge the battery with the DC to DC board step up with current limits that I currently don't have, so I've ordered such a board. And of course I've isolated everything very well in order to prevent short, and I have the fuse on the battery pack, 5 amps, and everything should be fine. Just adding the last board, and when it is disconnected, the battery will charge automatically, because I have a direct contact to the batteries that will go from the DC to DC. This is this wire and this wire direct to the battery, and these are the wires that have 12 volt input. So this is one board, and everything will be good to go. Again, demonstration, it is on, the power in is okay, but when I disconnect it, the light will turn on, a very strong light that can light all this room. This is 18 watt light, and this is how you make your own emergency light. And then you can of course install it on the wall with the mounting screws here carefully, and this is how it works. So that's all for now. Thank you and bye.